Good morning, everyone. My subject is compiler design, and I'm going to explain syntax analysis topic. Now, let us discuss what is syntax analysis. The syntax analysis is the second phases of compiler design. It takes the input as a source of tokens, and it will produce the parse tree. Now, let us see this. The parser or syntax analyzer receives the source code in the form of tokens from the lexicon analyzer and perform the syntax analysis, which creates a tree-like intermediate representation that depicts the grammatical structure of the token stream. So this, the parser means the syntax analyzer. It receives the source code in the form of tokens from the lexicon analyzer and perform the syntax analysis. So which creates a tree-like intermediate representation that depicts the grammatical structure of a token stream. The syntax analysis is also called as parsing. The syntax analysis is also called as parsing. A typical representation is abstract syntax tree in which each interior node represents an operation. The children of the node represent the arguments of the operation. Now let us see the small structure about syntax analyzer. So this is the source program, lexical analyzer, and parser and rest of content and intermediate representation. The parser means it's a syntax analyzer, and this is a token. See this lexical analyzer. It takes input as a source program and it reads the character by character and reproduce the output as a stream of token. Then parse tree is a second piece of compiler. It takes the input as a source, input as the stream of tokens from lexicon analyzer, and it will produce the syntax tree. It will produce the parse tree. Produce the parse tree. If it's any syntax error or semantics are available, error handler will handle that errors. Again, that parser is request for next token. Request for next token, and the lexicon analyzer will produce the stream of token. And these errors and information about identifiers, you can store it in the symbol table. The symbol table you can use to store the information about identifiers. And tell me the rule of parser. What are the rules are there? First, see this, it checks the stream of words and their parts of speech for a grammatical correctness. So that means it check the stream of words. That means check the grammatical correctness. Then determines if the input is syntactically well formed or not. So guides checking at a deeper values than syntax semantic checking. So builds an higher representation of the code. So now study of parsing. So first already we know that what is a parser. So it needs the syntax or programming language construct which can be specified by context-free grammar. It needs an algorithm for testing membership in a language for the grammar. So we are using some different parsing techniques are there. There are top-down parsing and bottom-up parsing. And as the top-down parsing, you can use the backtracking and non-backtracking methods in the and here bottom-up parsing we are using different parsing techniques LR0, SLR, LALR, LR1 and LRK. So LR0 is academic interest only and SLR means simple LR can parse some interesting languages. LR1 is very powerful parsing technology. The, the implementation of LR1 can get widely. Engineers try to rewrite their grammar into LALR1. The most real computer languages can be expressed as a LALR1 grammar. So the YAG, CUP, and CST tools and the Stable 6 tools parser generator requires the classes of grammar. Now, what are the benefits offered by this grammar? So, what are the benefits offered by this grammar? The first is the grammar gives the processes that easy to understand the syntactic specification to the grammaric languages. And parser can automatically be constructed for a certain classes of grammar. The parser construction process that can reveal the syntactic ambiguities and the trouble spots. The grammar imparts structure to languages. The structure is useful for translating source program into correct object code and for detecting the errors. The grammar allows a language to be evolved. The new construct can be integrated more easily into an implementation that follows the grammatical structure of the language. Now let us discuss what is context-free grammar. Context-free grammar is a shortcut to intelligent CFG. So it's a full form of CFG means context-free grammar. The context-free grammar is a four components: a set of terminal symbols, sometimes referred to as a token; set of non-terminal symbols, sometimes called as syntactic variables. So one non-terminal is distinguished as the start symbol, as a set of productions in the form of LHS and RHS. The terminals are elementary symbol of the language defined by the grammar. The non-terminal imposes hierarchical structure on the languages that is key to syntax analysis and translation. So take this example of simple arithmetic operations by using CFG expression plus term or expression, term or term. So here term implies term star factor or term or factor or factor. A factor implies the expressions are ID. Here expression, term and factors are non-terminals and ID plus minus star are terminals. Expressions is the start symbol. So and derivations. A grammar is derived a string by beginning with the start symbol and repeatedly replacing the non-terminal by body of productions for the non-terminal. This sequence of replacement is called derivations. Derivations means a grammar derives the strings by beginning with the start symbol and repeatedly replacing the non-terminal by the body of productions for that non-terminal. This sequence of replacement is called derivation. So the grammar derivation is expressions implies expressions of operators, expressions or expression number. Operators plus minus star. So this is the example of derivations. Thank you.